Grade 11s, this is a video about the calculations of delta H for exo and endothermic reactions. There are two ways to calculate delta H. The first way is to work with the formula energy in minus energy out. So that means that is the energy that will be given to a reaction that takes place during activation and the amount of energy that is then given off. So you will basically have to work with whatever the energy that's taken up by the reactants minus the energy out when the products are formed. Okay, so roughly you need to remember that. Now, this is going to link later on with our graph, and I want to just point that out, the delta H energy hump graph that looks like this. If we look at this type of graph, you know that that amount of energy there is called the activation energy. Now that would be, and here's your reactants. Now that would be your energy in, your reactants part. The amount of energy given off is that part. Right? So that is energy out. So you will take the amount of energy in, let's write this in here as well, energy in minus the energy out. Right, so you will then be given a reaction, maybe a hypothetical reaction, or you will know exactly what the amount of energy is per reactant that is given, taken up by the reaction, and you will then subtract the other side. Now I will work through an example like this in a different video. The other method will be where you say delta H is your final heat of the reaction, your enthalpy change. Remember, enthalpy is about the energy absorbed and energy given off. So it's the final energy minus the initial energy, or the heat of the reaction, the final heat minus the initial heat, which is then read off here. This is your initial and that is your final. And remember, this is your potential energy that is measured in kilojoule per mole, and this is your progress of reaction. Right? So therefore for this one you will then basically just take whatever the final reading is and you will subtract the initial from it. So if I now take a simple example in which I'm going to just put values onto my graph, I'm going to say let that be a reading of 20, let that one be 50, and that one 80. So let's see. In terms of method 1, delta H is equal to, now the amount of energy in is from 20 up to 80, that is 60, and energy out will be from 80 down to 50, that is 30. So my reading, or my delta H in that first method, will be 30 kilojoules per mole. If I take my second formula, it will be the HF minus HI. So HF is 50 minus HI, which is 20, and I get the same answer. And that is the point of the whole thing. The fact that you get the same answer of 30 kilojoules per mole, doing it in two different ways by just referring to different places, right? So energy in was for reactants, energy out for products, understanding where that came from, and then HF here is basically your products. So that one there is your products minus reactants. So there's actually, it almost feels like it's the other way around, but I hope that you understand that better by referring to these two examples.